Guys and girls, it's Know-It time! Know-It time!
So the next lesson I'm going to teach you is something called the sign law. Sign law. I'm pretty sure for most of you this is the first time you dealt with this. I'm not sure if you did this in grade 10. How many of you did this in grade 10 before? One? What? Sam, you came from India, that's why?
No, I came from Bangladesh. Yeah, I did know.
India, Bangladesh, you say potato? I say potato. How is it? Oh, is it? Oh, that's why I teach math, guys. I don't teach social studies. Well. Australians came from Asia, you know that. Everyone come from Asia. You know that. Like if you trace your blood back in your ancestor days, you're probably 1% Chinese. 1%. I'm sorry, but you're tainted. You're 1% Chinese. Somehow, back in the days. Here we go. Sign law. Before I can do the sign law, I'm going to get back to basics. Grade 9, grade 10. You work with right triangles. Keep it simple. And let's say we'll use a classic 3, 4, 5, and this was theta. And they ask you find theta. Find theta. Solve it. Probably grade 9, grade 10, this is what you did. And you can use any technique you like, besides looking at the person beside you. See, the moment you have 90 degrees, Amar, what technique did you use? Oh, you didn't start. Yeah. Kristal, what did you use? Goodness gracious me. Hartaj? Risham? Sine. What would you do? Sine theta for now? Equals to? Yep. 305. And then you take your calculator out. Let's whip it out. And you went second function sine. 3 divided by 5. And you have roughly 37 degrees. Okay, that was easy. Yeah, I said roughly. 37 degrees. See, you can do this. I'm going to write a few things down. Sokatoa. Sokatoa. Or I call it Sokato. Only works. This is crucial. A lot of people don't realize this. But it only works with a right triangle. If you don't see a right triangle, you can't Sokatoa anymore. This is a rule. See, here's 90 degrees. I see 90 degrees, so I can use Sokatoa. Now, but in reality, a lot of times you're given triangles that are not right triangles. So, for example, I'm going to give you a little triangle. Let's work with. Let's use this one. No longer do you have 90 degrees. Some of you say, but Mr. No, doesn't this look like 90 degrees? I can't say because I didn't put in that symbol. So I'm going to show you a new trick. To solve triangles that are not 90 degrees, triangles that are not 90 degrees, you must use. Now there's two ways of doing this. I'm going to show you the first method today. There's two methods of solving this. First, most common used one is something called the sign law. This is a short form for spelling sign, S-I-N. Sounds like a sin. Okay? I know. That's the short way of the sign. And for cosine law, they call it coleslaw. Yummy coleslaw. Every time I go to KFC, I always order coleslaw. Yummy stuff. Hey. Don't hate. I love KFC. It's my favorite thing. Every time I go to potluck, my friend knows me as the KFC guy because I always bring KFC. And I have a potluck coming up this Friday, and my friend already knows what I'm going to bring. KFC. Yeah. I know. Every day, there's going to be a quiz in my class. I'm very predictable. Yep. Oh, tan law? No. Tan law is what I do at the beach. How I get tan. Okay, that was your cheesy joke of the day. So I'm going to show you the sine law. Here's how it works. We're going to write down big A, capital letter B, capital letter C. The capital letter stands for the angle. Remember this. Opposite of big A, little a. Opposite of big B, little b. Opposite of big C, little c. I'm going to write a few things down. That's exactly how. A, all the capital letters are angles. All the little ones are side length. Okay, side length. Keep it simple. So what the sine law says is this. Sine of an angle. Any angle you like. For this one I chose A. Over the opposite side. So if I'm using angle A, I have to use the opposite side. That's the rule, which is little a. Okay. Now some of you say, Mr. No, why did you choose A? Well, technically you could have chosen B. So they're all the same. You can say sine A, sine B over B. Some of you say, why chose B? If you want, you can also choose C. But in reality, what I want you to focus on is sine of an angle over the opposite side equals to sine of another angle over opposite side. Potato, potato. Okay, give you an example. I have an angle. This is, let's say, 75 degrees. This here is 14. I'm just making random numbers. 36 degrees. Find x. I'm going to pause it. See, I'm given two angles and sort of two sides. So I'm going to set it up right now. The key is you got to use an angle and opposite side. If they're given, you know I can use sine law. I go sine 75 equals to sine 36 over x. Now, a lot of you got up to here and said, what did I do next? Well, grab your calculators, figure this out. I'm going to work with the left side first. Okay? So we'll go sine 75 divided by 14. Write this down, 0.0689. There's many ways of doing this. So 0.0689 equals to sine 36 over x. Guys, girls, a lot of you like to cross multiply. You can go ahead and cross multiply right now and solve it. If I cross multiply or isolate for x, I get x equals to sine 36 over 0.0689. Okay? So I just cross multiplied and I just did one extra step. You should be able to follow along. And that gives me sine 36 divided by 0.0689, 8.53. So this missing side is 8.53. Next question. What is this missing angle right now? Oh, please. Even my grade 8s can figure this one out. What is that missing angle? I'll give you a hint. All triangles must add up to something. Voila. See, I go one. And that's how you do it. Moving on. Try this one, a bit more challenging. Oh, please. $50 degrees. This here is x. This here is 11. Your job is to find x. I'm gonna show you the first mistake students make. Here's the first mistake. They go sine 50 over 11 equals to sine 70 over x. That's the first mistake students normally make. What's wrong with this?
It's wrong.
Which part is wrong?
The 70
The 70 is wrong. Okay. See, the reason it's wrong is because, remember, the whole process sine law is this. Sine of an angle over the opposite side. You have to use the opposite side. If I'm looking for this side, I have to use this angle right here. So this little angle is 60 degrees. That's where you went wrong. So let's erase 70, put in 60, and just solve it on your own right now. Many ways of doing this. Some of you say, Mr. No, can I cross multiply this right off the bat? You could. Or some of you like to just work with the left side first. Okay. I'm going to do the opposite way this time. I'm going to cross multiply. So you got x sine 50 equals to 11 sine 60. And go ahead and solve it. So x equals to, see, there's many ways of approaching this question. You can cross multiply first, or you can go ahead and simply solve it. Guys, gals, solve it right now. 11 times sine 60 times sine 60 divided by sine 50. Bada bing, bada boom. 12.4. Okay, so this number really is actually 12.4. Few more questions before I give you your work for today. This is sine law. Like I said, you're not ready for it yet. but I want to give you such a hard question. Mr. No, it's so hard. We're not ready for that question. Here is try next one. This time I'm going to get you to find an angle. This, I'm going to say, is going to be 44 degrees. I'm going to make up random numbers. This is 13. 7. Find x and find y and find z. A lot of things you got to do in one question. So I'm going to pause it. See, I'm looking for x, y, z, and I notice I'm given this opposite side, so I have to work with angle x first. I'm going to write down my equation. Sine x over 13 equals to, I choose an angle, and I choose the opposite side. Well, there's only one angle and opposite side I know now. Sine 44 over 7. Take a minute and solve it. Some of you are stuck here. Grab your calculator right now. I'm going to work with the right side first. Sine 44 divided by 7. You have 0.099, so let's write this down. Sine x over 13 equals to 0.099. Take a minute and bring the 13 over. Okay, I'm going to multiply that by 13. Sine x equals to, I'm going to multiply this by 13 now, 1.29. But now, how do you find x? Inverse sine, so let's inverse sine. And the moment you do inverse sine, look what happens. It says error. What this means is this. Error. It means x equals to error, which means you can never have a triangle that has 44, 13, 7. No such triangle can ever exist. So it's the way it's designed. So if I ever give you a protractor and a ruler and I ask you to draw this out, you can never have it that way because there's an error. I'm going to give you a question now with no error. So this is sometimes you will get an error in it. Let's give you a question. Sorry? Could be. You will. That's what after lunch is for. Try this one. So when you get an error, what it really means is, let's make this triangle now. This is 36 degrees. 23.4. 24.8. I'm going to ask you to find what is missing angle X right here. And that's it for now. X is this part right here. If you're stuck, you gotta understand what the whole concept of sine law is. The whole concept of sine law is I choose an angle and the opposite side. Well, right off the bat, I know there's an angle. Sine 36 over 24.8. See, I use opposite side. Now, a lot of you made a mistake by doing this. You went sine x over 23.4. The problem with this method is, if I'm using x, I have to use the opposite side. The opposite side is here. But I can't use the 23.4. If I'm going to use 23.4, really, I can't use x. So why don't we just make another letter? We'll call this a. Okay? Whatever you like. We'll call it sine a. I want you to solve for angle a right now. To find angle a, look what I'm going to do. Many methods of doing this. I'm going to go sine 36 divided by 24.8. See, I'm just solving the left side. Gets you 0.023. So let's write this down. 0.0237 equals to sine A over 23.4. Bring 23.4 over. Times 23.4. 0.554. But I'm solving for A, so you got to do one more thing. Inverse sine. Second function sine. And when I do, look what I get. 33.7 degrees, for, let's say. A equals to 33.7. But my question never asked you to find A. My question asked you to find X. Once you have A, go find X. So to find X, we go 180 minus 36 minus 33.7. 180 minus 36 minus 33.7. 110.3, so roughly 110 degrees. Hi. You say potato? Oh, when you do this, keep as many decimal places as you can till the end. Sig figs, please. Try this one. Sometimes they'll give you in words. It says triangle. I may not. I think you have one. I think I can give you one. Triangle LMN. Angle L equals to 64 degrees. L equals to 25.2 cm. N. Little m is 16.5 cm. Find angle N. Sometimes they won't draw the diagram out. I want you to draw the diagram out. I have triangle L, M, and N. Angle L is 64. Little l is this. Little m is this. Your job is to find angle N. I'm going to pause it. And a little hint. Guys, gals, that's what your picture should look like. It's a triangle. Okay. Where does LMN go? It doesn't matter. You choose. I'm going to choose, say, this is big L, big M, big N. And I'm going to start labeling. 64 degrees is here. 25.2. See, notice I'm using opposites. Opposite of the angle, opposite side. M, 16.5. What they're really looking for is this angle right here. Whoa. Something's wrong. Oh. I erased it. Sorry, that thing should be wrong. That should be 16.5. So this is 16.5. Now, guys and gals, we're going to find angle N. To find angle N, you're going to need to know what this missing angle theta is first. So right off the bat, set up the question. Sine 64 over 25.2 equals to sine theta over 16.5. And let's punch in our calculator right now. Sorry, what would you get for theta? Oh, you got the final? Okay, let me give you a second. Times inverse sine 0.588496 36 degrees. So we know this angle is 36. Theta equals to 36. Guys, gals, just punch in your calculator now. All my triangles add up to 180. So this one has to be 80 degrees. Voila. I'm going to teach you how to do the next one, which is, I'm going to give you a break. You guys can practice with this. We're going to do word problems later. Sorry? A value of sine, there's no such thing. Sine is a ratio. So there's whatever you want it to be. It depends on the question. So if you're looking for an actual number like pi, there's no such thing. Sine is a ratio. It's opposite. It means opposite over hypotenuse. That's what sine really is. It's a ratio. It's not an actual number.
My sine, it says here I did sine and then I equal it, and it's 0.9848752.
I'll explain that later, but for now, guys, I want you to copy this down. Page 108. Numero 2, 3, 4, 5. I want you to ace it for me, please. 2, 3, 4, 5. I'm gonna end our lesson here.